Hello, um, hello. Um, Today we are going to do a second night session of Leetcode. I'm planning on solving two problems, which is find median from data stream, and the other one would be partition equal subsets. Um, those problems are pretty important at this point because they are finishing 1DDP and heap priority queue problem sets. Then I'll probably be moving to graphs and greedy, as well as practicing some 2DDP and other 1DDP problems because I have definitely not mastered these 1DDP problems. Even though I have solved them, I solved them like a month ago and I probably don't remember them as well. Next would be intervals, merge intervals, minimum interval to include each query. I don't know why would Leetcode make a new category of intervals, but it looks good, I guess. Tries. Haven't solved any of them. So like let's just jump in to find median from data stream. The median is the middle value in an ordered integer, ordered, not sorted, uh, middle value. All right. If the size of this list is even, there is no middle value, and the median is the mean of two middle values. All right, this makes sense. For example, this median is 3, median is this. Implement the median finder class. Median finder initializes the median finder object. Yeah, this might leave empty because in Leetcode I have seen that in some problems when you're initializing a class, the constructor doesn't really do anything. Uh, Void add number, that's the integer num, from the data stream to the data structure. All right, what data structure? Like, what should be the underlying thing? It should probably be some kind of heap, but at this point, I don't understand what should it be. Double find median returns the median of all elements so far. Answers within of the actual answer will be expected. This is weird. Why would this be the case? Like, why would the answer not be a actual answer and just within this? Right, this is how it works. Median finder, well, it's initialized, add number, 1 is added, add number, 2 is added, find median. Nothing is inputted, add number, 3 is added, and find median. Output, yeah, here is 1.5 obviously, and here is 2 obviously. Right. Um, this is important because in case of even sized lists, we need to get the mean of two numbers, which might end up being a float. So floats are not gonna be completely accurate, I guess, in our calculations, but let's see. Median is the middle value of an integer list. Follow up. If all integer numbers from the stream are in range 100, how would you optimize your solution? If often and range, how would you optimize your solution? Those are really good questions. Topics, 2 pointers, design, sorting, heap priority queue. Right. Add number. like median finder, like what should be the underlying data structure, data stream? Like we can do a vector, like 1, 2, 3, just a vector, and we append. Adding number means appending, and what else gonna happen here? What else? What else should we should have a middle pointer, right? We should have another variable that saves a pointer to the mid, and this returns vector mid, vector pushback no. This should be all right. What is wrong with this? Now something is wrong with this, because this is a hard problem, and the solution is very easy. It's very plain. So I don't trust this. Now I don't get any other new ideas, so I'll just look into a write-up here. For example, all right, median is this. We get this. Median finder, initialize median finder. We get this. Example 1, we went through this. Should be 2. All right. Wait. What is this? And addnum 1, find median, it's 1. Addnum 3, find median, 2. Alright? Addnum 2 and find median, this should be 3. No? No. Oh, this is sorted. One, two, three. Oh, there is something so wrong with this. No, this should be sorted. No, this is not sorted. We get 2, 1, 2, 3. Addnum 1, addnum 2, addnum 3. And 1, 5, and 2. 1, 2, 3. 1, 2, 3. No, I think this is wrong. This might be wrong. Time and space. You should aim for solution with log n time for addnum and O1 time for find median. Right, this sounds good, but how? And O n space, where n is current number of elements. Let's trim in an array and sort it each time to find the median. What? Sort it each time to find the median? What kind of... Why sort it? Why sort it? I don't get it. Why sort it? Sorting. It's just a stream. A median is the middle value in a sorted list of integers. What? No, this is not what median is. Median is just a middle number, literally. In an ordered integer list. When I say ordered, does this mean median is 3 ordered integer list? Discussion. If all the numbers from a string are between, how to optimize it? This question in a phone screen to solve it just because I had a Leetcode a couple days earlier. I didn't notice it was hard. The same company, while houses can change the course of my career. Wow. Important posts from discussion. I was asked the question in interview today. Min heap and max heap approach. Got it done pretty soon. 2 heaps in a real interval. Further from Leetcode problem. Oh, this is a stupid question, but at least is a synonym for it being sorted. Ah, okay. Every element is greater than the previous element. Ordered, difference between ordered and sorted. Sorted would simply ordering according to implementation or comparable comparator. Ordered would imply that it is following the insertion order or some other definition. Arbitrary. So a sorted list of strings would be good. Ordered list, a numbered list of items. No, this is. Are we doing the same thing? Sorted list of integers. Alright, this is just stupid. Ordered integer list. Alright, just hint. Perhaps using a data structure that allows efficient insertion and retrieval of median can make solution more efficient. If we divide array in 2 parts, we can find the median in O1. If the left half can efficiently return the maximum and the right half can efficiently return the minimum, these values determine the median. However, the process changes slightly if the total number of elements is odd. In that case, if the total number of elements is odd, in that case, the median is the element from the half with the larger size. From the half with the larger size. Can you think of data structure which is suitable to implement this? Max heap for the left half and min heap for the right half. Instead of dividing the array, we store the elements in these heaps as they arrive in data stream. But how can you maintain equal halves of this element in 2 heaps? And how do you implement this? Hint 2, we initialize max heap and min heap when adding an element. If the element is greater than the minimum element, is greater than the minimum element of the min heap, we push it into the min heap. Otherwise, we push it into max heap. If the size difference between 2 heaps becomes greater than 1, we rebalance them by popping an element from the larger heap and pushing it into the smaller heap. This process ensures that the elements are evenly distributed between the 2 heaps. The middle element in all one time. Yeah, sort data begin. Alright, this is what's done. Just a vector. Push back, sort, that size, and 1. smart, very smart. And one. Data n plus 2. So when you divide, is this rounded up? It is rounded up. Because if n is 5, if n is, no, it has to be, n is data size. If n is 6, 0, 1, 2, 3, 4, 5, 2 and 3, 2 and 3. Where m is the number of function calls and n is the length of an array. M is the number of function calls and time complexity, number of function calls, and n is the length of an array. All right. Push add number. So adding a number is a Can we get more examples from here? 1, 2, 3. Just this. All right, this ordered means sorted, probably. Whatever, endeavor, just a vector of ints. All right, vector int data pushback num sort data dot begin data dot end int n equals data dot size for da 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 da. I think this is bad. And so if I hate the stupid bitwise operations, you know, like if n divided by 2 1, this is odd. Return data and divide by 2. Else return 2 plus data and divide by 2. So, you know, like 2, 1, 3. 3 divided by 2 is gonna be 1, right? I mean, this is plus 1. No. What the hell? Addressing buffer. heap heap buffer overflow. So if n is 2 minus 1, oh my god, this is ridiculous. Don't even see out. Don't even see out. This works. Sorting works. Time limit exceeded. So sorting won't work. Why? Like, why is this? I don't get. Why is that? Oh, I get it. I get it. I get it. So n is not 3. N is really 4. So when 4 gets divided by 2, it's 2. And we need to do minus 1, so it's 1. I get this. I also get this. I get this. The thing is that it's not a fast algorithm. So we should median from data stream sorted. Right. This is very easy. This heap. Now we're gonna have a less int small heap. I think small heap is gonna be a max heap. Is this a max heap or min heap? Plus max heap. Max heap. I know the std priority queue is the default template argument to the compare template is already max heap by default. Smallest element to appear at the top. That's a super controversial. Alright, priority queue. Priority queue int vector int. Of ints vector int. I think this means that it's implemented with vector less int. Is this also right? Less int. Brothers can't talk shit. Oh, like oof, adding is gonna be a hard one. How do we find the median? All right. If small heap, less heap, how do we know? Oh, all right, all right, all right. So if food, food, or should I help you? دخمر بگیداد. Else if, else if, small heap size. All right, now what happens here? This is where I get this small heap push. So it starts by heap pushing to small heap. If large heap is not empty and small heap top is more than large heap top, large heap push, small heap top, small heap pop. I think this is poorly written. Well, so if large heap is empty, then if small heap size is more than da 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 da, push. All right, I think I get this. So if the size difference is bigger than 1, pop from one and push it to another. Pop from one and push to another. If size difference is 1, or pop for 1, push it to another. I think this is what they are trying to do. But here I don't get this stuff. Small heap, push not. And if so, by default, it gets to a small heap. But if this number is bigger than large heap, oh, this is so cool. Now let's visualize. This is basically a solution, right? We have a small heap, some small heap. What was that? Oh, a small heap. Some numbers. And biggest. Biggest of small numbers. And then we have smallest of big numbers. And then we have a large heap, or what is it called? Small heap. Small heap, large heap. Heap, this one, large heap. And then this is essentially sorted. This is not sorted, but all right. So if our current number is bigger than the smallest of big numbers, it should go to a large heap. All right, at first, small heap dot push num push this. If small heap dot top is bigger than the large heap top, we need to swap them up. But we can't do this operation if we are not sure that, well, top, and eventually that empty and small to top is bigger than. And then if small heap dot size more than a large heap size plus 1, basically do that, to do the same thing, And this should work. Priority queue. Hooray! Right. That was good. That was, I guess, a productive problem solving. It took me 40 minutes. Given an integer array nums, return 3 if you can partition the array into two subsets such that sum of the elements in both subsets is equal or false. Two subsets that sum of the elements in both subsets is equal or false otherwise. We can partition. Honestly, I have, like, looking at this problem, I have zero idea. So I'm just gonna whatever. I'm just gonna see the write-up. If you are given an array of positive integer nums, return 3 if you can partition it into subset 1 and subset 2, where some subset equals, all right, 1, 2, 3, 4. This is true because we can do 1 and 4 and 2 and 3, and also that's it. False because we can't do it. Hint 1. If the sum of the array elements is not even, we can immediately return false. Think in terms of recursion, where we want to build a subset with a sum equal to half recursion. We try to build a subset with sum equal to half of the total sum. This makes sense. Actually makes sense. So we are trying to build a subset that has sum divided by 2. If we find such a subset, the remaining elements will automatically form another subset with the same sum. The entire array can also be considered as one subset, with the other being empty. Can you visualize this as a decision tree to process the array recursively? No, I cannot. We recursively iterate through the array with index I. At each step, we decide whether to include the element in the subset or not. Instead of forming the subset explicitly, can you think of a better approach? Maybe you only need to track the subset sum rather than generating the subset itself. Right, this makes sense. It's gonna be like a backtracking subset, like all subsets, generating all subsets. These can be, I think this is a backtracking issue. We can track the subset sum using a variable cursum. At each step, we make two recursive calls. If adding the current element does not exceed the target, we include it. If either path leads to a solution, we immediately return true. Can you determine the base case for this recursion? All elements in the array are positive. The base case will be if cursum equals also some element, we return true. This is what I was gonna say. If index I goes out of bounds, we return false. This solution is exponential, but we can use memoization to cache recursive calls, call results, and avoid redundant computations. We can use a hash map for a 2D array with dimensions n times t. Dimensions, we would have n numbers, and t is what? T is half the sum of the input, half the sum. T is half the sum, target, half the sum. All right, in sum equals 0 for, all right, we just get a sum, but I think there is a better way of doing this. If sum equals false, return DFS, so we just return this DFS. Return DFS nums 0. So our target is sum divided by 2. We give it nums array or vector and 0 index. I plus 1, I plus 1. Target equals 0. If I equals num size, return target equals 0. All right, return false. Return false here. So we do not, so in this call, we do not include the current num. Here we do include the current num. All right, let's code this solution up. It's gonna be can partition and right, in sum equals 0 for and in nums sum and. All right. Now we need to return DFS, or just call it helper. I don't like calling it DFS. Depth first search. Enjoy calling it DFS. Return helper. Nums 0 and sum divided by 2. Right. Sum divided 2 will be a whole number, because if it was not whole number, we already returned false. All right, DFS. Bool helper vector int. Whoa. That's int I and its target. So if we have to do it, if it already exceeded. So the sum has not been met. The sum has already been over added, I guess. Just fuck off. Fuck off, guys. Nabozari, Nabozari. Oh, I should check it. So the time limited has been exceeded, which is an obvious thing. Now memorization is really important here, I guess. We have a vector of ints. We memo what? Memo I target equals this. Alright, for this I and for this target, DFS is this. This is bull. I don't. You know what I don't get is um I get this memo I on a given index to a given target. Can we reach from this target? But this is bool. This is bool. It's gonna be bool. So C++ bool to int. Bool to int conversion in C++. Convert it to 1. So false is 0 and true is 1. True is 1. And we have -1 because it's not set. Alright. Memo or vector of hints memo. We have this memo thing going on. Memo for this given I, this given target equals this. If memo I to the target has been set, right? I do have one question. Like, how do we target 1 include or don't include? So this target can be reached from this index. Can this target be reached from this index, by either So when um, target reached. This is easy, I guess. Runtime. All right. Oh, we can't initialize the size of this here, but we can definitely, for sure, helper memo dot resize nums dot size. No. How is it? Target. And the target is gonna be just vector of ints, but it's really going to be like sum divided by 2, I guess. 2 plus 1. Y plus 1. Minus 1. Just initialize this to minus 1. Alright, sum divided by 2, what is that? What is that? Divided by 2, vector of ints, sum divided by 2, target. So the target is sum divided by 2, but y plus 1. I think we need plus 1 because we also need a 0 index, right? Submit. Um, Alright. That's it for today, guys. That's it for today. Alright. That's it for today, guys. That's it for today.